In the previous section, we graphed the solution to a linear inequality. In this section, we're going to graph the solutions, or the solution to a system of inequalities. So for example, in the first one, we want to graph the region, that means shade in the xy plane, shade the region that is satisfied by both of these two inequalities. So let's individually shade the solution to this inequality and this inequality, and then we'll discuss after that what the solution to the problem is. Okay, so the first thing we're going to do is get y on the left-hand side so that we have them in a slope-intercept type form. So the first one, I'm going to get 3y. I'm going to subtract 4x from both sides. So I get greater equal negative 4x plus 12. And then we'll divide everything by 3 to get y greater equal negative 4 over 3x plus, and 12 over 3 is equal to 4. So this inequality is equivalent to this one. And we have it in the correct form. So let's go ahead and work on this one, and then we'll finish this one over here. So I have a greater or equal. That means I'm going to shade an upper half plane, and I'm going to use a solid line because it's got the greater than or equal. And again, the upper half plane comes from the fact that y is greater than or equal. If y is greater than or equal, we shade the upper half plane. Less than or equal or less than, we do the lower half plane. So let's see, this one has a y-intercept of 4. 1, 2, 3, 4. And the slope is negative 4 over 3. That means go down 4 to the right 3. Okay, so I'm going to connect those two like so. And the upper half plane means we shade. I'm going to do it lightly. That half plane. Now let's move on to the second inequality. If I want to get y by itself on the left-hand side, I would start off with negative y less or equal negative x. All I did is subtract x from both sides. And now I need to get y instead of negative y, so I have to multiply both sides by negative 1, but you must remember when you multiply both sides of an inequality by a negative, multiply or divide by a negative, you have to reverse the inequality. So when I multiply both sides by negative 1, I get y greater equal x. So this inequality is equivalent to this one, and it's in the correct form. So if I were going to graph the line associated with this, similar to we did before, this line that we did before is y equals negative 4/3 x plus 4. Now we're going to graph y equals x, and that line looks like this, the 45-degree angle line. Has a slope, has a y-intercept of 0 and a slope of 1. So go up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1. And it's an equal, so we did the solid line, and it's greater than or equal, so we do upper half plane, and I'll go ahead and write solid. So what's the upper half plane going to look like? It's going to look like this, 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 that. Well, we've got a little bit of a messy graph here. What is the solution to this problem? The solution is we need to shade the region that is satisfied by both of these linear inequalities. So the solution, the region that is satisfied by both of these, is the one region in the graph that is shaded by both inequalities. This region right here is only shaded by one of the inequalities. This region right here is only shaded by one of the inequalities. This region here is shaded by neither of the inequalities. But notice this region here is shaded by both of the inequalities. So the solution is this region. And of course it goes on forever in all of those directions. That line extends, that line extends. So you could think of it as being maybe almost a fourth of the xy plane. If you think of it as quadrants almost, we've got 1, 2, 3, 4 quadrants. This is the quadrant that represents the solution. And what that means is every point that's shaded in this, every point in this region, I don't want to cross out the inequality there. Every point here, every xy pair, for example, 1, 2, 3, 1, 2, 3, 4, 5. Here's a point 3, 5. If I plug x equals 3 and y equals 5 into this equation, it's a true statement. If I plug x equals 3 and y equals 5, that'd be 3 minus 5 for negative 2. Negative 2 is indeed less than or equal to 0. If I plug in a point down here, I'm putting an x there, don't shade this region. Any point in this region, it wouldn't satisfy either of these two inequalities. This region will satisfy exactly one of them. This region would satisfy exactly one of them. So our solution again is simply this quadrant region we're shading. And if I wanted to, and I probably should, put arrows there because we know it goes on forever. All right, well, let's look at number 2. What is the solution set for a system of inequalities? Well, we just discussed it. It is the set of all xy pairs that satisfy every inequality. Can't just satisfy one, it has to satisfy both of them. And in some problems, in a few minutes, as a matter of fact, we're going to have 3 inequalities. If you have 3 inequalities, the solution is a set of xy pairs that satisfy all 3 of the inequalities. And we would never have this, but if you had a system of 10 inequalities, then the solution would be the set of all the xy pairs that satisfy all 10 inequalities. Basically, it's all of the ordered pairs that are in every single one of the half planes associated with your inequalities. All right, so number 3, kind of a recipe here. How do you graph the solution set for a system of inequalities? First, graph the system of equalities, which I'll write down as equations. And where do the equations come from? They're obtained by replacing each inequality, no matter which one it is, which of those 4, with an equal sign. That gives you a line. And remember to use a dashed line for the strict inequalities for this first one and third one, and use a solid line for the second one and the fourth one, the ones that include the equal sign. Next, shade lightly the half plane associated with each inequality. Then your final solution, the solution set, the final region to shade, is the single region that is shaded by every single half plane. And once you're done, this is called the feasibility set, or the feasibility region, and we'll figure out, or we'll learn why later. So from the very first example, this would be my feasibility set. I'll just put FS there. This whole region would be called the feasibility set. And lastly, in this video, usually in most real-life applications, we're only interested in quadrant 1. And hopefully you remember that. This is quadrant 1, 2, 3, and quadrant 4. So what that means is we'll have two inequalities that say x greater than 0, greater than or equal to 0, and y greater than or equal to 0. When this is the case, we're only interested in quadrant number 1.